Alrighty then. Exciting stuff going on, and more to come. You can see some activity there in the southwestern limb of the closest star. Thanks for stargazing with us here at the Smash News Network, least busted name in news. And this imagery here, this is a composite series of images from SDO. It's Iron Star, 335, 193 plus 94 angstroms. And this produced a significant coronal mass ejection. We'll get to it with some spectacular imagery. Here's 335 angstroms by itself. Crazy imagery of the closest star. And here's another composite. This is 211, 304, and 171 angstroms. Coronal mass ejections, coronal holes, geomagnetic storms, and more being covered on today's daily space weather. Brief look at volcanoes here. We saw a downtick yesterday. It looks like we still have a little downtick here, although Abiko still erupting in an explosive fashion, producing a flight level 110. It's an 11,000-foot ash plume over Paramushir Island. Subanose Jima also exploding. Unknown volcanic ash cloud. Please don't pole vault the caldera. Semeru in East Java, Indonesia, flight level 140. It's a 14,000-foot ash plume. Headed down to Colombia in South America, 21,000-foot ash plume over Nevado del Ruiz as it explodes. 26,000-foot ash plume over Sangay in Ecuador. That is an uptick at Sangay. Flight level 160 at Revenador in that same nation as it explodes as well. 16,000-foot ash plume over Revenador. 22,000-foot ash plume over Peru caused by explosive activity at Sabancaya. Brief look at seismicity to show us, well, really it is an earthquake drought here over the past 90 days. Only 2 7-magnitude quakes represented by those red bars. Largest quake of the past 24 was a 5.5 at Timor-Leste. That was at extreme depth. Over 480 kilometers estimated depth for that quake. And there has been indeed an earthquake swarm there around Indonesia. Remember, folks, any earthquake can be a foreshock. So hoping to not see the big one preparing to happen there in Indonesia. That is a tsunami-prone area. Chile also saw a 5.3. A couple quakes there around Japan, including a 5.1. And most recently, at 7:46 Universal Time this morning, a 5.4 near Sulawesi, Indonesia. So here's the CME that was associated with that flare you can see happening in the southwestern quadrant. Quite significant CME indeed. Is there an earthly directed component? I think there is a minor earth directed component with that. It's quite diffuse though, and we're not expecting it to last very long. If it does strike Earth, we could expect that to hit late in the day on the 20th, early in the day on the 21st. So some spectacular imagery there from the SDO and the Soho Lasco C2. Here's a close-up of what's going on down there. You see that plasma ejecting there, and then some plasma splashing back down to the chromosphere and reorienting. We've also slowed it down for you and included an Earth scale. That was 30 frames per second. This is only 10 frames per second. You see some plasma leaving and some plasma returning toward the surface of the closest star. And once again, thanks for stargazing with us here at the Smash News Network, least busted name in news. Here's a different series of wavelengths. This is 335 plus 193 angstroms. This previous one was 304 plus 193. Here's 335 plus 193, and we're using 193 because it's good at showing filaments. Just great imagery there of that sunspot and the associated plasma activity. There's the CME, and there's the splashdown. Here's some more coronagraph imagery. And it may look like a halo, but this ejecta here is actually on the far side of the sun. We'll show you more detail on that from Stereo A later in the video. Here's a slightly more zoomed in view. And yowzers. We're still awaiting a high-speed coronal hole wind stream as well. So the radial flux has dipped. Solar activity has dipped in general despite all of that activity. And we say all the time in the channel that, remember folks, you don't need to see solar flares or even sunspots to see coronal mass ejections. That's just the way it is. The radial flux now down to 123 solar flux units. There's the 1-year chart to contextualize that. It's the black line, and if you're looking, you can see how proportional the black line and the red line is. Black line is the radial flux. The red line is the sunspot number. So Space Weather Enthusiast dashboard, this is NOAA's forecast, expecting continued unrest and geomagnetic storm conditions all the way into Saturday, August 20th. So expecting continued activity here from more CME strikes and a high-speed coronal hole wind stream. At the moment, things are quite calm despite an elevated solar wind speed. We'll get to that information first. I'll look at the last 4 hours of Earth's geospace. So we've got a high-pressure plasma environment surrounding planet Earth right now. This is the last 4 hours modeled by the Space Weather Modeling Framework of magnetohydrodynamic pressure. The units for magnetohydrodynamic pressure are nanopascals. And we'll also show Earth's magnetic moment from the ground. That was Earth's magnetic moment from space. Here it is from the ground. This will show you the most likely areas to see aurorae. It's geospace delta B, changes to Earth B field. And it has refreshed. Let's let that play all the way through there. And let us know in the comments if you've seen aurorae, or hit us up on Twitter. Twitter.com/Smashomash. We're all over the internet at Smashomash. You can find links on the homepage and below the video to all kinds of additional stuff. Again, that's the last 4 hours of Earth's magnetic moment from the ground. And something we shared with our Smash Team members yesterday. We also did include a link on Twitter. This didn't require a login at smashomash.com/SmashTeam. The geoelectric field. So one of the things that we see during geomagnetic storm conditions is induction into the power grid. And this empirical data will give you some idea of what's going on with that. And you can see some significant spikes there. This will happen long before we see warnings from the Space Weather Prediction Center, long before we see KP index increases, because this happens all but instantaneously. So fortunately, there's circuitry to protect most first world countries' power grids. Let's take a look at geomagnetism. So we did see about 6 hours there of geomagnetic storm conditions. We never got to a KP7, at least not yet, although we are expecting additional high-speed plasma to be showing up in the coming days. So looking at the real-time solar wind next. Again, we do have an elevated solar wind speed. Now this could be the onset of a coronal hole high-speed stream, which we can expect to last a couple days. And this could mask some coronal mass ejection effects, as those CMEs, they weren't exactly earthly directed, at least as far as we could tell. So you see this uptick here to about 22 protons per cubic centimeter in the solar wind density, followed by a downtick and then a slow, steady rise in the solar wind speed. That looks like the onset of a coronal hole high-speed stream to me. And the reason we haven't seen continued geomagnetic storm conditions is because, well, we're not seeing a continued negative BZ. This red line up here, if that suddenly turns negative, and it is trending that way now, then we'll see geomagnetic storm conditions return. At the moment, the field not that strong. It's only at 10 nanotesla, and the BT is positive 2. Current solar wind density about 10 protons per cubic centimeter. Solar wind speed here approaching 600 kilometers per second, so that's quite fast. Also, we did see a little increase here in the plasma temperature. GOES magnetometers are all over the place, as are typical readings there during a series of plasma events. It's plasma from space. We saw some quite high readings there. And we can expect to see rather spiky sawtooth readings there on the GOES 16 and GOES 17 magnetometers. Heliospheric current sheet remains steady. Earth is in a south pole current sheet shown here in red. Yes, solar plasma, it's polar. Here's our line of sight plot. As solar cycle 25 progresses, we're seeing the north solar polar field sort of hiding itself here behind some plasma. It's largely on the other side of the sun here, but large portions of it are still around the north heliographic polar region. Here are those massive series of south pole oriented coronal holes here. That's most of the south solar polar field right in front of the Earth. And lots of coronal holes there. Here's the 211 angstroms wavelength. Very well defined coronal hole systems. They're all south pole oriented. Next thing we'll do is look at sunspots. And we've had a reduction here in sunspots over the past 24 hours. Little reduction in sunspots and a reduction in the radio flux. Still quite a few named groups. And as 3078 approaches the limb, don't be surprised to see an X-class flare come out of this sunspot, because this sunspot has been quite active here in terms of solar flares, otherwise known as X-rays. And as that approaches the limb, it becomes much more likely to produce large flares. It's already produced many large flares. And toying with the idea that solar flares may be anisotropic, meaning they might be a different intensity from a different viewing angle. We can't wait until somebody puts an X-ray scope out at stereo A or at stereo B. Lagrangian point 5 or Lagrangian point 4. So here's the colorized magnetogram for yesterday and today. Again, a minor reduction here in sunspot activity. Should also be reflected in the intensity gram. 3078 has been mostly stable over the past 24 hours. This group up here in the northeast degrading a bit. And let's continue on. And there's the X-ray flux over the past 3 days, and we've got an M-class flare happening while we stream the video. So there you go. We've got a minor M-class flare happening there. Maybe we haven't reached the peak yet, but at the moment it's in the M-class range. So this is the last 24 hours and 131 angstroms. And in that you'll see at least 2 M-class flares in there and a bunch of C-class flares mixed in. We'll also show 94 angstroms, the other wavelength that takes 10 images per minute instead of only 2. If you want to make your own slowed down images there from helioviewer.org, use 131 and or 94 angstroms. Those wavelengths are specifically formulated to study solar flares. And we zoomed into this scale here to include all the active regions since we showed you so many close-ups earlier in the video. And let's continue on. We've got plenty more information to blast through. No spikes in the proton flux here, so no relativistic particles associated with those solar flares. And here's a star chart. If you're up before dawn, you may see Jupiter, the Moon, and Saturn. I mean, Jupiter, the Moon, Mars, and Venus. Oh my God, Venus has Cancer. Oh no, never mind. Venus is in Cancer. Dear God. And let's do a solar system forecast. Mercury is heading around to the more populated side of the solar system, and Venus is becoming lonely on the opposite side of the Sun. Here's your 1-week forecast from theplanetstoday.com. And we'll have a crescent waning moon as we approach another new moon at the end of August. That's where planets will be located. Next, looking at coronagraphs. you're going to see quite a significant CME there. I believe there is a minor Earth-directed component to that, but not a major one. It may look like a halo. There is a CME on the opposite side of the sun sort of happening at the same time there. That's yesterday's coronagraph imagery. And here's today's so far, 27 frames. And we're also going to show the view from Stereo A because we've got a great pause here. Stereo A here located at Lagrange 5. Soho Lasco C3 located here at Lagrange 1. We pause there at 1738 for Stereo A and 1754 Universal Time for the Soho Lasco C3. And it may look like a halo. There is a partial halo here, so I believe part of this is earthly directed. However, this large loop over here is on the far side of the sun. So if you look on Stereo A, you can see this loop right here. That loop right there is this loop. But there is also a halo. So you can see a little bit of a halo there, indication that part of that is earthly directed. Now, most will miss to the southwest. Some will strike Earth most likely. So let's just let that play through. More great imagery there from Stereo A and the Soho Lasco C3. Again, we can expect that to arrive early in the day on the 21st or late in the day on the 20th. Now we're looking at hydrogen alpha imagery from the ground-based solar observatory, part of the National Sunspot Observatory. This one's located at El Teide, Spain. And we've still got a huge number of filaments, mainly in the northern hemisphere, but some in the south as well. You can see the ejection of that. All that activity from Sunspot 3078 has been interesting, to say the least. And we've got even more to cover. Here's the last about 3 hours from the GOES 16 SUVI. We should have an M-class flare showing up there. Right at the end of the video there, an M-class flare happening. Once again, as we stream live. So, shout out to Helios, aka El Sol, aka the closest star, the local yellow dwarf, otherwise known as the Sun. This is the last 24 hours in 171 angstroms. And it's time to go into bonus features. Starting out with the satellite's community dashboard to see some charging hazards here. These are surface charging hazards caused by low-energy electrons building up on the surfaces of satellites. And thanks for leaving comments, Tinman1057, and One Audio. Good morning to you two as well. Here at the Smash News Network, least busted name in news, we cover facts, not conjecture and nonsense. So anyway, there you go, some charging hazards over Mexico caused by low-energy electrons on the surfaces of satellites. Also, some minor charging hazards over the Caribbean and the Central Pacific. Electron flux has cratered as we forecasted. This is a common feature of coronal hole high-speed streams. The GOES 16 and GOES 17 are geosynchronous near-equatorial satellites who use radiography to measure the electron flux at the F layer of the ionosphere. So they're way up high, and they're measuring the electron flux at about 300 kilometers of altitude. They're located at about 10,500 miles of altitude, and they're using radiography to measure the electron flux at about 300 kilometers of altitude. And there's the forecast model. And you're going to see this. The next yellow diamond is going to be well below this green square, as we're seeing more nominal levels of electron flux here. So there's the one-year chart to put it in context. You're going to see this dip down by tomorrow's video. And let's take a look at the F ionosphere layer, where those electrons are measured, and we're going to look at it in vibrational frequency. This is the F-layer. And this data is courtesy of Australian Government Bureau of Meteorology. Don't worry if you're not used to looking at this. We will show the anomalygram as well. This is vibrational frequency, raw megahertz. And this is the anomalygram, anomaly in megahertz from the 30-day median. Now remember, folks, we are approaching September. September is the most geomagnetically active month of the year. So things have only begun to get interesting. And once again, make sure you follow us on Twitter. If you don't have an account, create an account over on Twitter. Help us reach a whopping 300 followers. And here's the latest image. That's 10:15 Universal Time anomalygram. There's the ionogram, vibrational frequency in megahertz, or millions of vibrations per second. Ionogram, anomalygram, anomaly in megahertz from the 30-day median. Continuing on with our bonus features, we're looking at the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, and we are seeing some electrons way out of place down here in the Southern Ocean and around Antarctica. This is also a typical feature of lower levels of electron flux. The electrons tend to be more organized with higher levels of electron flux. And seeing some anomalous electrons. This will show you the most likely spots for GPS errors. Most of them occur around the equator at noontime. Coincidentally, the same place where you see the highest levels of ultraviolet radiation. It's actually not coincidental at all. It's actually just basic physics. Anyway, that's the total electron content forecast. The most likely places for GPS errors are where you see red blobs. Your GPS satellite's located about 12,500 miles of altitude, right on the inner portion of the outer Van Allen belt. And when your GPS must communicate through a lot of electrons, you get a refracted signal, which can cause errors of thousands of miles. Let's get back to the closest star. There's your latest intensitygram. Whoops. There's your latest magnetogram. Once again, as this sunspot 3078 approaches the limb, it becomes very likely to produce massive solar flares. It looks like it's actually degrading here, but it's still quite magnetically complex. And as we just showed you, it's still producing M-class flares. Likelihood of additional coronal mass ejections still very high. And what haven't we viewed yet? How about 171 plus colorized magnetogram? This is yesterday plus today. Before we close out our space weather section of the video, and move into the realm of meteorology. Yes, it's a value-added service. And before we get into the meteorology, let's pause for station identification. Welcome to the Smash News Network, least busted name in news. Whew. Press like and subscribe if you enjoy the content. Tell your friends and foes about us. We've been making the most detailed space weather videos in the world for over 5 years. Thanks to everybody who's tuned in and put up with the pathetic censorship on the YouTube platform. Congratulations on realizing the channel exists. There are also cosmology segments, product reviews, and all kinds of other things on our playlist, so check those out. You can find links below the video and all over the place. If you want to support the channel, since we make just this side of nothing to put the videos on YouTube, consider becoming a gold or silver Smash Team member at smashomash.com/SmashTeam. Did you know we've already revealed the mechanism that underlies the solar cycles and solar polar field and solar sunspot cycles? We've already revealed it to our gold Smash Team members at smashomash.com/SmashTeam. Again, links below the video. Also, make sure you follow us on Twitch. If you weren't aware, twitch.tv/smashomash is a spot where we regularly stream live, especially when exciting things are happening. Again, make sure you follow us on Twitter as we approach 300 followers. It's very exciting, and you'll see some retweets there that you'll only see by following us on Twitter, twitter.com/smashomash. If you haven't checked out our merch shop, check it out. Save 25% on all clothing with promo code INSPIRED. Enter the promo code INSPIRED on checkout through Friday, August 19th to get 25% off any clothing purchase. And that's order of best selling. Today's featured product is Do Not Pole Vault the Caldera. So don't pole vault the Caldera, folks. No matter how good your field team is, leave your vault pole at home if you're going to visit a volcano. It's inappropriate to pole vault volcanic calderae, especially active ones. So please don't. We don't want to breathe you in at a later time. Don't pick a permanent solution to a temporary problem. Smash Staff and I have got the products, some of them, like the socks, for example, which are quite comfy, by the way, and the print quality is massive. So pick up some merch, support the channel that way, give Smash Staff a raise. And if you're wondering, I'm not only Smash-O-Mash, but I'm also a client. So, of course, got to wear the products. Maybe it's too controversial. I don't know. I don't know why it would be controversial at all to not divulge your protected health information, but for some reason, it's been. In any case, do not pole vault the Caldera. Our finest days lie ahead. And if you're going through hell, keep going. One thing that can prevent you from going through hell is joining SureMed. You'll save all kinds of money on prescriptions, diagnostic testing. You won't have to physically go to the doctor because you can use a teledoc service, otherwise known as doctors by phone. If you're losing your you-know-what, you can contact counselors by phone. There are even virtual veterinarians. Yeah, SureMed. Find the link below the video as well as on our homepage to that. It's spectacular, and believe it or not, I actually use it myself. Links on the homepage to that as well as below the video, smashomash.com. Welcome to the Neo-Renaissance. You know, the weird thing about science, folks, is sometimes when you immerse yourself in the data, you ask questions about the physical universe, and sometimes you don't receive answers to the questions, but instead you receive answers to questions not asked. So be open to it and be closed to the nonsense that shows up on YouTube. I know there are a lot of complete frauds and propagandists on YouTube. We put up facts on the channel, and we attempt to advance the science, not lock people into a pile of nonsense. So let's get to the space weather transition. We're transitioning from space weather to Earth weather. And sadly, the aurorae have calmed down here to the point where not a lot going on. And so we're actually looking at pressure. So this is our pressure map, and one of the lowest pressures in the world is in the Southern Ocean here, near Antarctica, 935 hectopascals down there. And let's briefly switch to the space portion. And there's the current auroral oval. Pretty pathetic here at the moment. Likelihood of seeing aurorae is kind of low. Anyway, let's move into meteorological stuff. And I would invite you all to understand the difference between space weather and Earth weather. We are looking at surface winds at the moment, which are indeed Earth weather. Now, you could make the argument that all of our weather comes from space, as the sun is heating up and cooling down the atmosphere and causing all kinds of convective patterns in the jet streams and so on. But there is a difference between Earth and space weather. Once again, those are your surface winds. Some strong winds there over central Australia. Here are the jet streams of the eastern world. Some backward jet stream there over Indonesia and the northern Indian Ocean. Here are the jet streams of the Americas. Yes. Cold air continues to blow down into the eastern U.S. there from central Canada. The jet stream dipping way down, bringing some cold temperatures. Here are the surface winds of the western world, the Americas. Strong low there continues, sort of in between Ireland and Iceland. Here are the surface winds of the central world, Europe, Africa, the Middle East. And here are the jet streams. Checking out the weather.gov map. If your county's lit, click your county on weather.gov. The weather map for the National Weather Service. And some additional flooding expected here in mainly New Mexico and Arizona, also some in southern Utah. Some gale warnings around Alaska and the California coast. Perhaps some good surfing. Also some heavy winds around New England and around the Outer Banks. So let's bring up a forecast here. We were unable to do it in show prep, so let's do a total accumulated precipitation forecast for the next 72 hours. This is the GFS model. And that is how you do it. TropicalTidbits.com. Again, that's your 72-hour GFS total accumulated precipitation forecast. And you can see heavy rains there showing up, especially in southern Arizona, central New Mexico, even parts of the Texas stovepipe. Expected to see 3+ inches of rain there. Rain shown there in inches on your GFS 72-hour total accumulated precipitation forecast. And let's continue on. We don't want the video to be too long, so let's do it. And here's your pressure map. Again, significant low pressures there in the Southern Ocean off the coast of Antarctica. Quite a few lows down there. Yowzers. 933 hectopascals. And here is the pressure environment for the Atlantic, the Pacific, and North America. Strong low here in between Kamchatka and Alaska, and a decent low there in eastern Maine. Leave us a comment if you've ever been to Cadillac Mountain, the first place in North America to see the sunrise. Next, your NASAGO's lightning mapper. That's where the cells have been for the past about 10 hours. Southern part of the U.S. seeing quite a bit of lightning. And here's a real-time lightning map. This is where things are currently. And we've got some terrestrial strikes here around the Louisiana-Mississippi border. Yowzers. There's thunder rolling in Jefferson County. Quite active cells happening there. Around the Gulf states. Next time you hear thunder, check it out, lightningmaps.org. You can frighten the natives by forecasting thunder. Try it, you'll like it. And next we've got your U.S. Doppler radar map. Heavy storms there in Louisiana and Mississippi, moving to the southeast. Also some significant storms there moving into Minnesota from North Dakota. And that low kicking up some rain there in northern New England, northern New York, and so on. Here's clouds and fog using a 3.9 nanometer radiation satellite. And before we show water vapor, one more time, I want to pause for station identification. This is the Smash News Network least busted name in news. And thanks for leaving a comment. Red split rail fence. Here's your water vapor map. You can see this dry mass of air pushing its way down to the south, pushing its way down to the south, creating massive pressure gradients as cold air rushes down from central Canada. Here's your recap. We'll attempt to zoom out here and show all 50 states. Shortwave radiation showing clouds and fog. And there is the water vapor. And that is where this video needs to end. Thanks for tuning in. Congratulations once again on realizing the channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off from the Smash News Network, least busted name in news, and may that solar wind be at your back.